Hello, this video will talk about triangle similarity and missing side lengths and right triangle proportions. I kind of stuck this in here at the last minute. Right triangle proportions. Just forgot to change the title. Alright, so we're talking about notes here. Triangles may be proven or justified similar by three different methods. In these three methods, you'll notice all of them have little squiggles. That just means similar or similarity. So the first one says AA similarity, then we have SAS similarity, and side-side-side SSS similarity, where corresponding angles are congruent and corresponding sides are in proportion. So I'm going to draw your attention over here to this right-hand side. This first pair of triangles, it's a little tough to see with the red on purplish. We have a pair of 60-degree angles, a pair of 80-degree angles, and a pair of 40-degree angles. So this means that the triangles are similar by AA similarity. This could also be AAA similarity. We just choose to only talk about 2 because 2 is the minimum amount that we need. The next one, if we look at this, we have a pair of congruent angles, but then we have some sides. And so I'm going to just set up a proportion to make sure that these triangles are in fact similar. So it looks like 12 will get mapped onto 36, and equal sign question mark. 15 gets mapped onto 45. In the last video, we talked about how we could solve this in one of two ways. You can either cross multiply, or you can simply reduce the fractions. If you have a TI Inspire, it's nice and easy to reduce your fractions. Just type in the fraction and hit enter. 12 divided by 36, if we reduce it in our calculator, would tell us that it's equal to 1/3. Same thing for 15 over 45. I could divide out by 15 on top and bottom, or just use my calculator, and we again get 1/3. So we have corresponding sides that are in proportion and a pair of congruent angles between the sides. So this set of triangles will be proven or justified similar by side, angle, side. And then our last one here, we have 6, 8, 10, 30, 40, 50. So I'm just going to check to see if all three pairs of sides are in proportion. So it looks like 6 will get mapped onto 30, 8 onto 40, and 10 onto 50. And I'm just going to go back and put question marks over these because we don't know if they're equal or not. Now, when we have three pairs of fractions, it's easiest to just reduce them instead of trying to cross multiply 3 different times. So we have 6 over 30 reduces to 1/5, 8 over 40, 1/5, 10 over 50, 1/5. So again, these are all equal, which means that the triangles are similar by side, side, side similarity. Now, the only method that's ever used in T-chart proofs, where you're writing statement and reason, is AA similarity. Since corresponding sides are in proportion, we also know that their corresponding perimeters are in proportion. And we could talk about the perimeters of triangles over here on the right side, 6, 8, 10, 30, 40, 50. If you were to sum these numbers, you would see that the ratio is still 1/5 because they're in proportion with the corresponding sides. Now, corresponding areas are in slightly different ratio. They are in a ratio of 1 to k squared, where that k is representing scale factor. So if I had a triangle like the one over here on the right-hand side with a 6 and an 8 as my base and my height, area equals 1/2 6 times 8, base times height, or length times width. 6 times 8 is 48, and half of that is 24. Then if I take a look at the other triangle, we have area equals 1/2 times 30 times 40. 30 times 40 is 1,200, and half of that is 600. Now you might be thinking, wow, that's a huge difference, and it's true. If we take 600 and divide it by 24, we end up with 25. And remember how I said that it's equal to 1 to k squared, scale factor squared? and our ratio or our scale factor was essentially 5, multiply by 5 to get 30, multiply by 5 to get 50, etc. Well, 5 squared is 25. So area does not grow just by the scale factor, it grows by scale factor squared. And kind of a trick to remember that is that area is always square units. Inches squared, centimeters squared, units squared. And so we have to square the scale factor as well. The next bullet we have to talk about is finding the third side in a right triangle using Pythagorean theorem, which of course is your a squared plus b squared equals c squared. And you can see the side lengths labeled over here, where c is always the hypotenuse. And here's my right angle, so I can identify c as the hypotenuse. And then lastly, we have right triangle proportions, where we have 3 different formulas: Hall, a squared ss, and leash. They kind of make words for you, so it's easy to remember the formulas. Something that you should notice about these formulas is that you always have 2 pieces of information on each side. So like HA is 2 pieces, LL is 2 pieces, A squared is 2 pieces, A and then the squared, equals SS, 2 more pieces. So each formula, Hall, A squared SS, and leash, have 2 pieces of information. Where H is the big hypotenuse. Notice I said focus on the big right triangle when we're labeling. So here's my right angle in the big triangle. That means AB is my hypotenuse. The hypotenuse then gets split up into 2 segments, S1, S2. The big right triangle also has legs. Legs make the right angle. So here, if I have S1 on the left side, that means up here I have L1. If I have S2 on the right side of the big triangle, I now have L2. And the only piece that ever gets labeled in the middle going through our triangle is the altitude, A. So again, we can use these 3 formulas to help us find any of these missing pieces on the right-hand side. We may have to use them in conjunction with Pythagorean theorem, because sometimes they don't give us enough information initially. However, these 3 formulas come in handy whenever we see pictures of a right triangle with an altitude drawn. Each of the following questions come from a Common Core exam that has been administered in the past, so they are at the level of rigor that you would need to be at in order to be successful in your Common Core geometry exam. So number 1 says that we have 2 triangles, ABC and DEC, that are similar. AC is 12. DC is 7, DE is 5, and the perimeter of triangle AEC is 30. What is the perimeter of triangle DEC? So I'm going to say P equals X. Again, I love to call the thing that we're missing X. So what we need to do here is just set up a proportion. We don't need to find missing side lengths, but we do need to make sure we're consistent when we set up our proportion. I'm going to choose to go with small over big. We could go big over small, it does not matter as long as we're consistent. So for example, X being the perimeter of the small, over 30 being the perimeter of the big, should be equal to, now we have to be careful here, because it says that ABC is similar to DEC, which means that AC matches with DC. So I want 7 small over 12 big. Some students tried to choose the 5 because it looks like 5's on the right side, so is the 12 of each triangle. However, you can see that those triangles are reflected and dilated, meaning they're flipped and shrunken or grown. So then we're just cross-multiplying and solving here. You can pause the video to do this yourself and then check back in to see that you have the correct answer, please. Alright, so for number 1, we should have choice 4. Number 2, triangles RST and XYZ are drawn below. RS is 6, ST is 14, XY is 9, YZ is 21, and angle S is congruent to angle Y. Is triangle RST similar to XYZ? Justify your answer. So this is where we need to think about our 3 methods of similarity. AA, similarity, SAS, similarity, and SSS, similarity. And we can kind of narrow it down actually to one choice. We do not have 2 pairs of congruent angles, so AA is out, nor do we have 3 pairs of given sides, so SSS is out. So we're hoping that if they're similar, it is by side, angle, side. We have to actually test it. So here we're going to say that we have, let's go again, small over big. 14 comes from ST. ST matches with XY. So 14 over 21 equal sign question mark 6 small over big 9. So again, you can either cross multiply this or you can just simply reduce the fractions. I like to just reduce them, it's easiest for me. So if I take 14 divided by 21 and reduce it, then we end up with 2/3. Same with 6/9, that does reduce to 2/3. And so if they are equal, that checks out. So we're going to say yes, by, and then because we narrowed it down to side, angle, side already, we're going to say yes, by, side, angle, side, similarity. Simple as that. You just have to remember to check all of your sides to see if they're in proportion and to make sure that there's one pair of congruent angles if you're not given all 3 pairs of sides. Number 3 is a typical multiple choice question that they like to ask. They give us a triangle that's dilated by a scale factor of 3 with the center of dilation at the origin. Which statement is true? So when I see questions like this, before I even attempt to answer them, I draw myself a picture. Triangle ABC is always a right triangle in my case, and I have the side lengths of 3, 4, 5. Every single time I choose this because it is a right triangle. Then it's growing by a scale factor of 3. So now I have A prime, B prime, C prime. If AC of 3 grows by a scale factor of 3, it now becomes 9. Just simply multiplying by 3. 4 times 3 is 12. 5 times 3 is 15. So now I can go through and answer these questions. It says that the area of the image is 9 times the area of the original. So we have to calculate the area of my purple triangle. 1/2 base times height, 3 times 4. 3 times 4 is 12. Take a half of that and we get 6. Then do the same thing for my other triangle, my pink one. Area equals 1/2, 9 times 12. So 1/2 of 108, which is 54. Now if we think about how to get from 6 to 54, we do in fact have to multiply by 9. 6 times 9 is 54. So number 1 is true. Now we're just going to double check our next option to make sure it's false. It says that the perimeter of the image is 9 times the perimeter of the original. So perimeter, oops, I should do this in purple to match my triangle. Perimeter is 3 plus 4 plus 5 for a total of 12. My pink triangle, we have perimeter equals 9 plus 12 plus 15 for a total of 36. Now in order to get from 12 to 36, we are simply multiplying by 3, or in other words, the scale factor. Now perimeter is supposed to be not 9 times, but 3 times. So here we're coming back to area being 9 times. This is that scale factor squared, k squared that we were talking about earlier. Or in other words, 3 squared, which is 9. Area always squared, so 1 is our answer. Now we didn't even take a look at choices 3 and 4, and the reason is because the choice 3 talks about slopes. We have not touched on slopes, nor do they change when you dilate, right? AC is horizontal, and so is A prime, C prime. The slope does not change. Same thing with the measure of the angles. The angles stay the same. Remember, that's why we have AA similarity. That means that the angles are congruent. All right, we're moving on. Number 4 says which transformation would result in the perimeter of a triangle being different than the perimeter of its image. So this ties back to Unit 3 where we talk about transformations, but it is talking about perimeters being different, which we do talk about here today. So if we were to eliminate any choices, it would be 1 and 2, because in this first one we're just reflecting. In the second one we are also, again, just reflecting. Reflections preserve distance, which means that it preserves perimeter size. And the next two, this is where we're thinking about, okay, which one of these changes the size? Now, if I start with this little triangle here, and I take the coordinates and I multiply them by 4, that means this point down here now comes out here. This point here now comes way up here. This one here comes way out here. Multiplying them by 4 is actually a dilation. Remember, when you multiply, that's your shrink or grow. And then if we just simply add or subtract, all it's doing is shifting. Over 2, down 5, so here. Over 2, down 5 here. Over 2, down 5 here. So now this triangle is actually the same size. This is our translation. So the only one that would change the size of the perimeter is choice 3. Alright, number 5 here is actually a word problem using those formulas that we talked about where we see this right triangle with an altitude drawn. So I'll give you a minute to just read this independently. You can pause the video if you need to. And then I want you to think about how to answer the first question, because this is a 2-part question. So it's asking us to find the distance between the park ranger station and the lifeguard chair, P to L. So I'm going to choose to place an X there where P and L are. And I'm looking at this triangle that's formed right there. I have an X, a 0.55, and a 0.25. Remember we briefly mentioned on the first page of our notes that we could find the third side of a right triangle using Pythagorean theorem. So I've got my A, my B, right angle across from that is always C. So we're just simply plugging in and then we're solving. 0.25 squared plus x squared equals 0.55 squared. 0.25 squared gives us 0.0625 plus x squared equals, now I'm typing in 0.55 squared, and we get 0.3025. Now our goal here is to solve for x, which means that we need to get x squared alone, or in other words, subtract 0.0625 from both sides. So now we have x squared equals, we're going to do that subtraction. You can do it in your own calculator while I do it on mine. 0.24. Now again, our goal is to get x by itself, but there's a squared attached. In order to undo squaring, we have to simply square root both sides. So we're going to square root 0.24, and we end up with x equals 0.48989. Now your calculator might have a little bit different at the very end. It depends on where it stops, where it rounds. But here we're rounding to the nearest hundredth. Hundredth is the second spot. Looking to the right, the 9 tells me to round the 8 up. So we have x equals 0.49. Now the next part says that Gerald believes the distance from the first aid station, that's F, to the campground, C, is at least, meaning greater than, 1.5 miles. Is Gerald correct? Justify your answer. So our goal here is to figure out what FC is, so say Y, and then determine if Gerald's correct. So this is where we come in with our H, A, L, and S. So I'm going to write those 3 formulas down off to the side. You do have to memorize them for your tests. They are not given on a reference sheet. Remember, it's 3 words. I will not say the second word for you, but you're welcome to say it yourself if you're comfortable. So we've got haul, A squared SS, and leash. So I'm looking at the given information, like this 0.55. That's a leg of my big triangle. And then this big Y that I marked on there, that's the big hypotenuse, my H. And so this piece, LC, is an S, meaning we're using that formula LSH, L squared equals SH. So we're just going to simply plug in here. We have 0.55 squared equals my segment 0.25 times my hypotenuse, Y. So we're going to solve this. We're going to ignore the fact that we're thinking about 1.5 for just a few minutes. So 0.55 squared, remember we just did that one, 3025 rather, equals 0.25 y. Our goal is to get y by itself, so get rid of the 0.25 in front of it by dividing. When we divide, we end up with 1.21. So here it says it's at least 1.5. Is Gerald correct? Well, we got 1.21, so at least means greater than, bigger than 1.5. So no, because the distance is only 1.21. Done. One more question on the next page and then you get to practice on your own. Number 6 says the aspect ratio, the ratio of screen width to height of a rectangular flat screen TV, is 16.9. The length of the diagonal of the screen of the television screen size. Determine and state to the nearest inch the screen size, meaning the diagonal, of the flat screen TV with a screen height of 20.6 inches. So what they're saying is that we have essentially a small TV here, a scale drawing of a TV, where the width to height is 16 to 9. Width to height 16 to 9. And then we have this actual TV. It looks a little squarish. It's not supposed to be square. Make it rectangular, please. Where the screen height is 20.6. And our goal is to figure out the length of the diagonal. Now, they give us no information about the scale drawing's diagonal length, and so we have to do a little bit of work before we can find that diagonal. Meaning, let's find this width of the actual TV first, because once we have two sides of a right triangle, we can easily find the third. So first step is to find x. And if we have a scale drawing, that means that we have proportions for side lengths. So we're going to go with 9 small over 20.6. This is height over height equals 16 over x, width over width. So we're going to cross multiply. 9x equals, I'm going to type this in the calculator, 16 times 20.6 is 329.6. We're going to divide by 9. And we get x equals 36.62222222 forever and ever and ever. Do not round yet. Keep that. Because if you round too early, your answer in the end might get messed up. So then the second step, I'm just going to erase so we have a little bit more room here, is to find the diagonal. Say y. So again, we've got our right triangle. If you imagine a TV, it makes a right angle at each of the corners. And we're trying to find the third side. So step 2 would be to use Pythagorean theorem, where A and B are your legs and C is your hypotenuse, the side you're looking for. So we have x squared, or in other words, 3.62222, or 36.62222 squared plus 20.6 squared equals y squared. So we're going to type this in. We're going to square that 36.222. 36.62222 squared is, wow, big number, 1,341.187 plus 20.6 squared, 424.36. We're going to add those two together because that's what it says to do after all. Now we get 1765.547 equals y squared. And remember, as we said on a previous example, to undo squaring, we have to do the opposite, meaning take the square root. So we end up with y equals 42.0184. And again, your decimals may be slightly different on the right-hand side depending on how your calculator is rounding for you. But it says to state to the nearest inch, so a whole number. So that means that we have a final answer of just 42. If you have any questions, of course, talk to the teacher that's there in front of you. Otherwise, go ahead and move on to the practice that you see here. If you need to rewind the video at any point in time, feel free to do so. Remember, this is here to help you in order to be successful on your Common Core exam in June. Good luck!